Hello, welcome to our discussion for the rational expression. So this is basically part of one of the topics in basic algebra. So this is a rational expression. And what is really a rational expression? So a rational expression is an expression of the form m over n, provided of course that your n is not zero and where m and n are expressions. So basically, a rational expression is of this form where the numerator and denominator are also expressions. So let's consider this for example. Let's consider this first example. So this is actually a rational expression provided that this thing here is not zero. Second, um, we also have this example. 4x minus 3y all over 3x squared minus 9x, provided, of course, that this denominator is not 0. So, of course, since we're dealing with rational expressions, so we will be talking about the operations of rational expressions. So first things first, we'll start with addition. So when I say addition, it could mean things like addition or merely subtraction, because subtraction is just a mere additive inverse of any positive number. So the rule for that, of course, is this one. First is we have to determine the least common denominator, or the so-called LCD. The LCD, or sometimes we call that one as LCM, or the least common multiple. So just not to be confused with this, we use the term LCD is when we mean that we're actually getting the least multiple of a given denominator of each rational expression. But when we're just using when we're just solving for the multiple of a certain type of expression, so we mean that as least common multiple. So next is when we get the LCD or the LCM, this thing becomes the denominator of the sum. And then that denominator or the LCD will be divided by each denominators of its addends on the given. And then the answer will be multiplied by the numerator of the corresponding addends. So let's say, for example, consider this one. Let's have x plus 1 over x plus 2 plus x minus 1 over x minus 1. Sorry, should be x minus 3 to be more realistic. So first is we get the LCD here. And then according to the rule, so we have to get first the LCD. So once we get the LCD here, so once we get this LCD, we have to divide this LCD by this, so that the corresponding denominator of each addend. And once we get the answer, we will multiply that by the corresponding numerator. So we write the answer here, plus, and we, again, divide this LCD by the corresponding denominator of another expression. And then the answer will be multiplied by the corresponding numerator. Then we write this one. And then we do the operation here via addition of expression. And then that will be our answer, depending if that will no longer be reducible. Otherwise, we have to reduce that based on what we have understood on our past knowledge about expressions. Okay, great. So what is really LCD? So LCD, or again, on the least common denominator, is what we call the least valued expression that can be a multiple of all terms. So first is we factor out each term and align the factor of one terms to the same factor of the other. Bring down all the aligned factors and then multiply. That's the rule. So there are only two rules to remember. First is we factor them out and align. And then once they're aligned, you have to bring them down and then you multiply. So that's our LCD. So let's consider this for example. So we have x squared minus 1 plus x plus 1. I'm sorry, x squared minus 1 and x plus 1 rather. So what are we going to do is here. Okay, hang on. So we have x squared plus minus 1. We also have here x plus 1. So we all know that the factor by a special product formula, x squared minus 1 is equal to x minus 1 and x plus 1. So basically, the product of x minus 1 and x plus 1 is x squared minus 1. And we all know that x plus 1 is actually simplified term already. So that means x plus 1 is just x plus 1. So what I do is I align these because they're actually the same. So I did not align x plus 1 with x minus 1. And then I bring them down. So bring this down here. So I'll have x minus 1. I'll bring this down here. I have x plus 1. So what's actually the product of these two? The product of these two is actually x squared minus 1. Therefore, this is now the LCD between, or the LCM between x squared minus 1 and x plus 1. Okay, let's consider this next example. What is the LCM of x squared minus 1 and x squared plus 2x plus 1? So again, what we're going to do is this way. X squared minus 1. I also have x squared plus 2x plus 1. So let's factor them out. Again, this x squared minus 1 is equal to x plus 1 and x minus 1. How about this? This will be will this be factored out? Oh yeah, sure. This will be factored out. So via special product formula, this will be a product of two x plus 1s. Therefore, I have x plus 1 here. But of course, another x plus 1 to get the product, which is equal to x squared plus 2x plus 1. However, x plus 1 is not the same as x minus 1 here. So I will not write it in here, but I write it in here. Okay? Hence, I will now have three terms. So I will bring them down. So I have x plus 1 here. I have x minus 1 here. And I also have x plus 1 here. Okay? So therefore, this will be my this will now be my result. So I have now x squared plus 2x plus 1 times x minus 1. So this will now be my LCD, whether I have to simplify them or I'll just let it this way. So I'll just let it this way because our purpose is just to get the LCM. Okay. So now that we're done with getting the LCM, so we will now apply this LCM to the rule of addition of rational expression. So we will get this way. So what is the sum of 4x plus 5 over x and 3x minus 1 all over x? So first is we have to get the LCM. However, the LCM of both rational expressions, they're actually the same. So therefore, the LCM is actually that expression. So therefore, the LCM here is, or the LCD is x only. So what's the rule again? You have to divide the LCD by the denominator on the first addend. What would be the result? You have to multiply that on the corresponding numerator. So here, x divided by x, you get 1. And you multiply 1 by 4x plus 5, which is the corresponding numerator. Therefore, you get 4x plus 5 here. Okay? And if you divide x by the second denominator, you'll get 1. and you multiply that with a corresponding numerator, you'll just get 3x minus 1. Therefore, if you do the sum here, so you'll get 7x plus 4 all over x. So this is now the final answer. Okay. So let's do another example here. So let's consider the addition of 4x plus 5 all over x squared minus 1 and 2x all over x plus 1. So again, we'll have to do it this way. Let's get first the LCD here. You have x squared minus 1. I'll get x plus 1 and x minus 1. And again, I have x plus 1 here. Although we have solved this already, but we want to have to repeat this for the purpose that it will be much more familiar with us. So I have x plus 1 here. So bring them down. I have x plus 1. I have x minus 1. Therefore, we already know that our LCD is x squared minus 1. Okay, so now that we're done with getting with the LCD, so for next that we have to do is, of course, since we already have the LCD here, so we will write this down here. So this is x squared minus 1. So this LCD will be divided by the first denominator, and of course, they're actually the same. So the quotient will be 1. So 1 multiplied by the corresponding numerator, you'll get, of course, 4x minus plus 5 rather. However, if you divide x squared minus 1 by x plus 1, you're pretty sure that what is left is x minus 1. So therefore, you multiply that by the corresponding 2x, so you have 2x times x minus 1. Okay? And so I have x squared minus 1 here. I have 4x plus 5. And I have to simplify this via distributive method. So I have 2x squared minus 2x. So this will now be my answer. I have 2x squared here. I'll arrange them into the highest degree form, although it's not really necessary, but for the purpose, for the aesthetic purpose of your expression, you'll have to arrange that from the highest degree to the lowest degree. So I'll write first 2x squared, and of course I can add 4x and 2x here, so I have 2x and I have 5 all over x squared minus 1. So this will now be my final answer. Okay, let's consider this. X plus 1 all over 2x squared plus 3x plus 1. I also have x minus 1 all over x squared minus x minus 2. Let's see. Let's get first the LCD for that. Excuse me. I have 2x squared plus 3x plus 1. What's the factor for these? I can write here 2x. I can write here x. I can write here 1. I can write here 1. So the factor actually will be, of course, 2x plus 1 and x plus 1. So this is via factoring method. So I assume that we are already done with this. Otherwise, you have to review with my past videos for the factoring method. So next is we have to get the factor of x squared minus x minus 2 here. So what are the factors of x squared minus x minus 2? So it could mean like I have x plus 1, and I have x minus 2. So therefore, we'll have to align them all. So I have 3 terms for my LCD. So I have 2x plus 1. I have x plus 1. And of course, I have x minus 2. So this will be my LCD now. So it's either I have to simplify them or I have to leave it that way. So I'll just copy that. So 2x plus 1 and x plus 1. And I have x minus 2. So this LCD will be divided by the first denominator. Note that the first denominator is equivalent to this. So what is left is I have x minus 2. So I have x plus 1 and x minus 2. So I multiply x plus 1 by x minus 2. Plus, if I divide this by this, what is left is 2x plus 1. So I have 2x plus 1. And I have x minus 1 here. So I can therefore simplify what is the expression above. So I have x this is x squared minus x minus 2, right? So x plus 1 times x minus 2. And this is actually 2x squared minus x minus 1, right? So this will be 2x squared. So I have 2x squared. I should have negative 2x, but there's a 1x here. So that will be minus x, and I have negative 1. All over. That would be fine if we have to simplify them if you wish to. Like simplifying the denominator. So sorry, I lost my cursor here. Hang on. Okay. Okay. So I can have I can have 2x squared plus 3x plus 1 times x minus 2. So basically this is equal to 3x squared, and I have 2x, and I would have negative 3 all over the product of these. So I shall have, let's do it, let's simplify this in this way. So I can have 2x cubed minus 4x squared plus 3x squared minus 6x plus x minus 2. So basically, I can just add here. This will be negative x squared. I can add this and this, so I'll have negative 5x. So therefore, what my final answer on the denominator will be 2x cubed minus x squared minus 5x minus 2. So this will now be my final answer. Okay? Okay, great. Okay, let's consider this another example. I have x plus 1, and I have all over 2x squared plus 3x plus 1 minus x minus 1 all over x squared minus x minus 2. I think we're done with these already. Sorry, my bad. So we're done with these already. So we have, okay, so we're done with addition already. So let's now go and focus on multiplication. So remember that we can do the process of addition and subtraction at the same time because they're actually the same. Multiplication and division are actually the same. There is only slight difference of the rule for division and multiplication. So let's consider the rule first. First is we can multiply numerator to numerator and denominator to denominator only. So you cannot merely multiply numerator via denominator. So that's not possible. So the only possible thing is, of course, numerator to numerator and denominator to denominator, of course. Next is before you do that, or of course, either you do the process for the first process before this, or you can either do this before that. So it depends on what is actually easier for you. So you can factor each term as possible, and once you factor them out, if the numerator and denominator have the same factor, you can cancel them out, or that's what we call simplification. Let's consider, for example, let's say I have one expression here. Um, where's my cursor? Okay, here. I have x plus 1 here, and I have x plus 2, and I have x plus 2 here over x plus 3. So there actually so there is an expression here in the numerator which is the same with the expression in the denominator. So in this case, we can cancel them out. Okay. So that's what I mean with the rule number 3. Okay, next is if the operation is by means of division. So this is now the additional rule for division. So if the operation is by means of division, you just need to get the reciprocal first of the divisor and proceed with multiplication. So you proceed with the same pattern with these first three. So example, you have x, I'm sorry. So you have x plus 1 here over x plus 2 divided by x minus 1 over x plus 2. So before you do the process of the first three rules, you need to get the reciprocal first of the divisor. So in this case, this is the divisor. So of course, this is the dividend. So this is the divisor. So you need to get the reciprocal first. So getting the reciprocal, that's x plus 2 over x minus 1. So since you do the, you're done with getting the reciprocal, so the division becomes now multiplication. And then you follow the first three rules. So you can cancel this out, you can cancel this out. So therefore you have x plus 1 over x minus 1. That's it. So let's consider for example here. Find the product of x squared plus 4x plus 4 all over x squared minus 1 and x squared plus 2x plus 1 all over 2x plus 4. Let's see here. So x squared plus 4x plus 4, I think we can write that. We can factor that out into, that's x plus 2 quantity squared because the product of these two x plus 2's is actually x squared plus 4x plus 4 all over x squared minus 1. I can factor that out into x plus 1 and x minus 1, right? So I can multiply these by, what's x squared plus 2x plus 1? Of course, that's x plus 1 quantity squared all over. I can write this as 2 times x plus 2. So this is basically 2x plus 4 here. So note that I have x plus 1 and I have x plus 1. So there are two x plus 1s on top. And at the bottom, there's only one x plus 1. So I can cancel this out. I will cancel these. So I left with 1 x plus 1. Same with these. I have x plus 2 on top. So I can cancel that 1 here. And I can cancel at the bottom 1x plus 2. So therefore, what I left is I have x plus 2 times x plus 1 all over 2x minus 1. So this will be your answer, or either you can simplify that into x squared plus 3x plus 2 all over 2x minus 2. Either of the two, they're actually the same. Okay, let's consider this for example now. I have 8x squared minus 32, and all over I have x cubed plus 6x squared plus 12x plus 8. And I have x squared plus 4x plus 4 all over x squared minus x minus 4. So this might be a little bit complicated. Not really complicated. It's just that we need to have our prior knowledge with special product factoring. So let's try this way. 8x squared minus 32. Observe that we can write these as, I can factor the 8 out. So I have 8. And so when I factor these, I left with, of course, x squared minus 4. And remember, x squared minus 4, I can write that as x plus 2 times x minus 2. Okay. How about these? This is actually x cubed. I can write this as 3 times 2 x squared. So basically, and this is actually 3 times 2 squared x, and this is 2 cubed. So basically, this is just the same as x plus 2 cubed. So I can multiply that with, how about this? X squared plus 4x plus 4, I can write that as x plus 2 squared. I also have x minus 2 and x plus 1. So I can cancel this out. I can cancel 2x plus 2's here because there are 2x plus 2's on top. And I still have 1 left here because there's 3. But there's another x plus 1 on top over here. So I can cancel this out and I can cancel this out. So what I left on top is just 8. And what I left at the bottom is x plus 1. So this will now be my final answer. So I still have a lot of examples for that, but it's up to you here. Let's say, for example, I have, let's find the quotient of these. So again, first things first is we'll have to get the reciprocal of the divisor. So in this case, this is our divisor here. So I can factor them out first. So x squared plus 6x plus 5, I can write that, of course, as x plus 5 times x plus 1 all over. I can write this below as x plus 5 over x minus 2. So if I get the reciprocal to get the multiplication, so this will now be my new numerator. So that's x minus 4 all over. I'm sorry, it would be better if I'll write this as squared here. So assuming this is squared, so I have x minus 2 here. This is x plus 2. And I can factor this out to be at the denominator. So I have x plus 1 quantity squared. So I cancel this out. I'll cancel this out. I'll cancel this out. I'll cancel this out. I'll cancel this. I cancel this. So what I have left is x plus 2 over x minus 1. I'm sorry, plus 1. That's it. So these are now examples for the rational expressions, the operation with addition or subtraction, and the multiplication or division. So if you want to find out more, a lot of things about basic algebra, you just have to subscribe here in my channel, and you will see a lot of videos I have to be uploading moving forward. So thank you so much for listening, and see you around. Bye for now.